Hi, your next challenge is called Make a Circle with OOP. If you don't know what that is, that's Object-Oriented Programming. And that's very exciting that we're getting more into this topic. So your task is to create a circle constructor that creates a circle with a radius provided by an argument. The circles constructed must have two getters. Getters are functions. GetArea and GetPerimeter, and they provide the formulas for those. That's not written out well, but it's supposed to say pi times r squared, and this one is supposed to say 2 times pi times r, with r being the radius. And it says which give both respective areas and perimeter, circumference in the case of a circle. For help with this class, I've provided you with a rectangle constructor, which you can use as a base example. Okay, we don't need that, but sure. Let's look at the example. You would pass in this argument, the constructor of the class, and if you remember from a recent video, the constructor is named after the class itself. And then this is how, remember, we used the new keyword to make an object, and so now we've instantiated the circle class. We have a specific instance of it. We made one. And from that, you can call its methods on it. And they gave an example using this getArea method. And they've created a new circle down here, which they didn't do well because they're declaring a circle with the same name. You know, this should either, you can either overwrite if you delete this circle and then just use the same name and kind of make a new object and assign to it, or he should have called this circy2 or something different. But anyway, here's one with 4.44, call perimeter, and you can use the formulas and multiply that out if you'd like to make sure that these values are right. The notes are, don't worry about floating point precision. I've factored in the chance that your answer may be more or less accurate than mine. This is more of a tutorial than a challenge, so the topic covered may be considered advanced, yet the challenge is more simple, so if this challenge gets labeled as easy, don't worry too much. Okay? We're not worried about it. We're going to be fine. So, yeah, this could be new. We haven't done a lot of OOP to this point. We did get a little bit of an introduction, so if you're just completely lost, feel free to proceed right into the solution. Ideally, you know, maybe you could look things up, read an article about it, but I'll leave that up to you to police yourself. So we'll go over to the code, and like he said, he gave us this rectangle class, which you could use as an example and sort of tailor as your own. And then he put a stub here for a circle class, and then we unquote this. This is the part needed to run. Okay, so we're good there. And then what I will do is I'll take these two methods. These are the two methods we need for the circle class. Drop those in. Do my formatting because OCD is real. Okay, so we know those are the two methods that we have to implement. These implementations definitely are not right for a circle. Do you remember for area it said pi and pi r squared, that is, and you should note that there is a pi value that's already made for us, so we don't have to write this out or anything like that. We can just tap this. So I'm going to use math pi. That's 2 uppercase letters times. Okay, so we're going to need the radius, right? First things first, let's get the constructor in. And if you remember, the constructor is public and it just takes the name of the class. It doesn't have a return type. It will actually return you an object of this class. But yeah, in our case, it was to take a double representing the radius. So now we have to do something with this argument that they gave us. We're going to persist it. It's part of the class. We're going to make a field to hold that. It's part of the the description of what a circle is. So I'm going to make my variable private. In a scenario, you may have reason to make that value accessible. You could give someone read-only access to it. But since we're sort of doing all the useful calculations, I'm just going to keep mine private and try to let the user not have to worry about it. The smaller you can keep your public interface, the better. And by that, I mean the things that have this public keyword that the user is going to use. I always put my public stuff first, and then if someone new comes and looks at the code, they can get a good idea of what the class says it does by looking at what's made public. So that can give someone a quick way to look through it. They don't have to scroll up and down, jumping all over the place trying to understand what it is I'm saying I'm doing with this class. So anyway, our radius was a double value, and I'm going to precede it with an underscore. We've talked about that before. It's a common convention for just denoting that something is part of the class. It's a member of this class. It's not some temporary variable that you'd see inside a method definition. This is something that persists with the class. And now that I have that, I can finish my implementation. Pi times radius squared is the same as pi times radius. And the perimeter formula they gave us was 2 times pi times the radius. So that should implement both of those correctly. One thing I missed in the constructor though, don't forget when they give you this input, we have to set the field so it gets initialized. That's very important. You can see in this call down here when we create it with 4.44, we need that value to go into our underscore radius field. That way, whenever these functions are later invoked, the radius is set to the proper value, So, yeah, I think that does it. We got the methods they said to implement. I'm going to remove this leftover from the rectangle class. And yeah, constructor, let's give this a run, see what happens. Cool, yeah. We passed all the tests, looks good. We're calculating area and perimeter correctly. And this is kind of cool. It's starting to feel like we're doing useful things that you would do in solving real problems. And that's cool. That's a nice checkpoint for you that you're progressing and you're going to be solving real problems. One thing, in reality, this get area and get perimeter, right? You're probably not dealing with just circles. You're probably dealing with rectangles, triangles, and various other shapes. So in order to sort of reuse this stuff, you would often see it implemented in what is called an interface. And so maybe I'll show that quick. It basically, you can think of an interface too as like a sort of contract that for any class that implements it, it's required to implement these methods. And that may make more sense once I put the code in. So let's try that. Let's try saying interface. And what are all these things generically? They're shapes, right? They're all shapes. Interface shape. And then we have those two methods. One returns double and it's called get area, and the other returns a double and it's called get perimeter. And so these methods have to be public, so it's not necessary to write that out. The interface would be useless if these could be private, so of course they're publicly accessible. But you don't implement them here. Just notice that I'm making a declaration. I'm not putting any code that says how to do get area, how to calculate it, because the problem is that we've stepped back into a more abstract place. We're just saying, hey, we're talking about this shape thing. That's really abstract, right? If someone told you to describe a shape, I mean, you'd probably think, hey, what do you mean? There's lots of shapes. And we do that on purpose. It's an abstraction. It's a sort of initial layer that factors out some of the common behaviors, right? We can call get area on a rectangle. We can call it on a triangle. We can call it on a circle. But it means very different things in each of those contexts. So this is nice that we can reuse this with all of those shapes, and then within each shape class itself we can say specifically what it does. In circle it was pi r squared. In the rectangle you would probably have a length and width field, and you just multiply those together, and it's all different. So to use this, you enter a colon, then you enter your interface name. And when we get to talking about polymorphism and inheritance, you'll see this same thing, the colon and then another class name. So we can also derive from other classes in the same way. In interface, other classes, you would use a comma separated list here if you had more than one item you wanted to inherit from. But once I enter this shape here, now my circle class is absolutely on the line for having methods named this. And in my case I do, but if I didn't, it would throw an error, it wouldn't compile. It would tell me, hey, if you're implementing the shape interface, you got to have these. If you don't have these, you're not a shape. That's the idea there. And so you could also imagine if I had public class triangle, I would say colon shape, because it's a shape too. And yeah, same for other shapes. Since we did that, let me see. Let me just refresh it and run it again so you can see that in action. Okay, go over to the code, reload it up, put what I had in there. So now our circle is a shape. Cool. We used an interface. We didn't have to here, but we're introducing concepts as they come along. Repetition will drive it home, so just try to follow along best you can. See, same thing. And that's cool. I can define what a shape is. Anything that shapes have in common, I could put in here. So yeah, maybe you'd add some kind of draw method, or anything you want that all shapes would have, you could put here in one place. And so there you have it. That was a nice continuation of object-oriented programming. And hit me up in the comments section rather. I know it's different, takes some getting used to. So yeah, happy to answer any questions you may have. Thanks again for watching.